The narrative has always been over the last few decades, stay out of the sun. Mm-hmm. But recently, people have started saying, no, it's actually you need to become accustomed to the sun, and the real issue is people using sunscreen all the time and then going out and getting burned. Obviously, your situation is very different because you have a specific gene.
And I'm Irish.
Yeah, so that's the problem, right?
Yeah,
the genes of the people that lived in cloudy-ass places for hundreds of thousands of years.
And my mother, when we were kids, I mean, I'm 64 years old, so when I was a kid, we'd go to the beach in Connecticut, and they'd smother me in coconut oil.
Oh, yeah. Right. Yeah, baby oil when I was a kid. Everybody had baby oil, and everybody got barbecued.
Yeah. Plus, I worked in the fields as a kid for, farm labor.
And that's not good.
That wasn't good.
The burning, that's the damage to the skin, and then it manifests itself as cancer far later in life, right?
Right. Yeah. There's all these subtle, let's call them smoldering mutations that are waiting for a second or a third hit to occur. Or for, instance, you get old enough so that your immune system is kind of going wonky, and it no longer is able to take care of something that 20 years ago it would have been able to heal perfectly well.
That makes sense. So is there any this narrative that you need to be in the sun more and that just don't get burned, is that reality?
Well, it depends on who. I mean, for someone like me, no. But there are positives, obviously, for the sun. I mean, vitamin D, as an example. But they're also, resetting your clock in the morning rather than taking melatonin at night. Go and just, in a bright, use glass to shield out the ultraviolet and get some bright light. It's the UV that's the danger. It's not light.
So, for you don't ever just go sit in the sun?
Not anymore. No, but I was...
Because of the melanoma.
Because I was an idiot when I was a kid. I mean, I would go use tanning beds because I thought, I wanted to look, tan.
Right.
And I did tan back then, but, obviously can't anymore.
Yeah, you don't really see those anymore, do you?
No. You do.
Maybe in, Seattle.
Some people do. Yeah, there's... I think there's a benefit to light. I mean, I'm not saying don't go out and do it. I think as well, there'll come a day, and I was just talking with some friends of mine at dinner last night, is, maybe with things like CRISPR, I could rub a CRISPR ointment on my body. It would fix the single point mutation in my skin, and then I could enjoy the sun again.
Is that really potentially down the pipe?
I think
How far away are we?
I think, honestly, people always say 5 years is sort of like this horizon. But, no, I know people who are already developing systems for delivering genes, RNA to cell. I know that's a dirty word in some, but there are formulations of RNA that probably won't be as problematic as some of the things that maybe the COVID vaccine might have done.
Right. Yeah. RNA right now, you say, and people clench.
Yes, exactly. Yeah. But your cells are full of RNA. Right. So, you can't get away from the fact that your cells are full of RNA.
It's just the messenger RNA.
Yeah. But it's also the means by which they delivered it, right? The means by which it was delivered was a formulation of a nucleotide that by itself was meant to be something called an adjuvant. An adjuvant is something which activates the immune system you want. When you get a vaccination, you are co-injected with something that hyperactivates the immune system to say, come hither.
Right.
And most of the pain that you get from an injection is not the vaccine itself, it's the adjuvant.
A spike protein factory.
Yeah. Well, at least locally.
Yeah.
Yeah. No, I've read some of the work.
But not always locally, right? Because they didn't aspirate with a lot of people.
Yeah.
Yeah.
I don't
think they aspirated with anybody. They didn't with the president on TV.
But if you get infected by a virus, it's over your whole body anyway. So It's whether the spike protein itself was problematic. And I know I'll annoy somebody one side or the other by saying anything around this area, and I'm not here to cause any controversy. But, your immune system works, but if you can trick your immune system into getting ahead of the game, then that's a good thing. The question is, back to this cost-benefit ratio, is the benefit to the larger statistical population worth it, knowing that some people are going to be hurt by it or not? That's the question. So for instance, back to cancer and vaccines, there's a number of cancer vaccines that are coming down the pike that for people like me would be, given that I get something chopped off of me 4 times a year.
Really?
Oh yeah, you should see me. I look like I've been in a war zone. Wow. Some people say, "Oh, that's hot,"
and that's the only. That's hot.
Wow.
Someone's into cutters.
Yeah, exactly. Exactly.
So that's so fascinating. But is there another way that could potentially deal with those things other than cutting them off, or is that the only way to remove it from your system?
Right now, it has to be cut off.
So the issue is that once the melanoma, once these lesions are on your skin, they will expand.
Yes. Luckily, most of mine have been called surface spreading, although one of mine was what's called a nodal, which basically dives right in. And believe it or not, my dog found it and was sniffing at it on my arm.
Really?
And started scratching at it, and it stopped bleeding. I'll show you the scar.
What kind of dog do you have?
This was 15 years ago. He was a Pomeranian. But, you can see the scar there.
Oh, that's crazy.
And it wouldn't stop bleeding. And so, I went in and had it looked at, and they said another week and it would have metastasized. Yeah.
Wow.
So, yeah. He has
a great dog.
He was great. Yeah, he was great. But, there are, so for instance, if you can catch most of these cancers early, then that's what's important. So I think probably one of the most important, let's say, changes to our medical system that could be initiated would be, frankly, the use of things like MRI, not CT scans, because CT scans are known to cause cancer.
Which is so crazy.
Yeah.
When did we figure that out?
There was a big study just published recently that said, here's what happens to people once CT scans were implemented, and you see this sudden spike in the... Again, it's this cost-benefit ratio. If you didn't have it, certain people wouldn't know that they have a giant tumor in there.
Right.
So for instance, I had, when I had kidney cancer, I was actually at a restaurant with friends doing a business deal, actually. And I went to the bathroom, and it was blood. And I said, okay, we got to go to the emergency room, now. And then they did a CT scan, and they see the brachial tree around my kidney was just a big diffuse mess, and they came in and said, you've got cancer.
Did you have to have your kidney removed?
Yeah. It was, but it's okay. I'm alive.
It's nice to have 2 of them.
Yes, exactly. I'm alive, but it is this early detection is important. I was lucky that it hadn't metastasized yet. It was called clear cell renal cell carcinoma. But so surveying the body, and these companies that are out there right now which do it, I think are really important, because even if you are young and you have no suspicion you're going to have cancer, having that baseline against which you can compare later changes is important. Because I could do, for instance, a CT scan or an MRI of you, and I'd find lots of little anomalies. And they're generally in the field called phantomas. They're these objects that may be worrisome, but we won't know that they're worrisome, and certainly not going to do a biopsy of them and poke a needle into your chest to pick out a piece of it. But if I come back 6 months and it's changed, then maybe it's something we need to go after, more seriously. So getting those kinds of regular scans, I think, is probably one of the more important things that could be done, but not by a CT scan.
Which is crazy, because we were doing them for so long.
Yeah.
Did they still do CT scans, though, because it's necessary?
It's necessary
the only way,
for certain things.
Right, which is letting people know this might cause cancer. Is just yikes.
Yeah, but maybe, for instance, there'd be a way to treat someone with a drug ahead of time that would minimize the effect of the CT scan. Right? So that, because the CT scans are generally causing oxidative damage. And so if you could provide a local antioxidant, and I'm not saying that something like this exists,
right.
It's a bit of a naive statement, but if you could do that locally to the area that's being imaged or to the whole body, then maybe CT scans could be lessened in their problematic outcomes.
I would say innovative and hopeful more
Okay,
than
yes.
I would naive.
Yeah.
I don't think it's naive because you're recognizing
Yeah.
the issue.
Right. Thank you.
This was also a problem with x-rays, right? Like
Oh, yeah.
x-ray technicians, like I've seen some of those images of people's hands because the technician used to have to use their own hand to check to make sure that the x-ray was functional.
Right.
And then over the years they go, hey, what the fuck is wrong with my hand? And then they realize, oh boy.
Right.
Yeah.
Well, it's interesting because what's happening with X-rays or CT scans is a fast forward of the kind of random damage that causes cancer in the first place. And so because it's random, but let me kind of go back a little bit as to why does cancer happen in the first place. So let's go way back in evolution to the first time that there were single cells versus the first time that two cells met each other and said it was better to join forces and cooperate rather than to divide at each other's expense. So in the process of that happening, those two cells came together, or three or four cells. They basically said, together we're better than alone. But there were actually social compacts and contracts that at the genetic level were being formed between all of these cells. And so as things got more and more complex contracts were formed, to the point at which what could happen is that any one of the breaking of a complex contract could actually then initiate a cascade that becomes cancer. So rather than we thinking of cancer as being a forward progression in evolution, it's actually another way to think about it is that it's a devolution back to the core fire of the desire to divide. And so by breaking the contracts, by breaking the controls on the system, cancer is allowed to blossom. So the problem is that every tissue type, whether you're lung or brain or whatever, has a whole different ecosystem of contracts that have been formed. And so there's no one-size-fits-all drug that will kill off all cancers because the contracts are different. It's not like you can bring in a lawyer and fix, agricultural contracts versus maritime or whatever.
Yeah.
So that's you have to have a flexible enough mindset, because if you get stuck in this, it's a forward evolution, as opposed to that it's a breaking of contracts, you might miss out on an opportunity for how to develop a therapy or a drug that would help people.
One of the things that I wanted to ask you, I don't even know if you know anything about this, but is there a connection between IVF and the amount of, because you have to take some pretty extreme hormones. There's a lot of stuff that women have to take. Is there a connection between that and hormonal-related tumors? I
honestly don't know, so I don't want to opine and then have half my colleagues send me emails tomorrow scolding me.
Okay, good. Well, I'm glad you answered that way. I was told by someone who I really trust that there is. And then we tried to Google it, and it said there's not, but that's not surprising.
Probably there hasn't been the right kind of study yet, and if there is not, there should be. I mean, certainly any hormonal imbalance is not a good thing. I mean, you imbalance the metabolism of the system, and you can... I mean, so for instance, back to my specific disease with mid-F, there's all kinds of things like N-acetylcysteine, betaine, all these other drugs that are out there for longevity. Well, if I look into the metabolism of what my cancer is, every single one of those is a disaster for me.
It accelerates.
Yeah.
Not good.
Not good. So, because there's all these feedback mechanisms.
Right.
I mean, people often say, scientists are not religious. There's nothing that inspires more awe in me than knowing the complexity of the cell and knowing the complexity of life.
Right.
And seeing all this feedback and mechanism and knowing that underneath that is a universe with particles, et cetera, that enabled something like us to exist. I just sit in awe of that.
Well, yeah, it's awe-inspiring for sure. I mean, anybody who doesn't think it is not paying attention, or they're purposely being ignorant.
Right.
Yeah. Well, you get a lot of that, though.
Oh, yeah. Well, that's okay. Teachers are here to hopefully teach and not preach.
Hopefully, yeah. Because of your specific type of cancer and your situation, do you have to, very closely monitor your diet?
I probably shouldn't eat as much meat as I do.
Meat?
Yeah.
Why meat?
Well, because, fats. And a lot of them, the fats dissolve a fair number of toxins. It's not necessarily a good thing. I mean, that's been relatively well shown that too much meat, as opposed to, I'm not advocating vegetarianism. I think there's a happy medium. I mean, we grew up in an environment where we had both. I mean, we're omnivores, and we succeeded, I think, because we're omnivores as a society, as a civilization. So, but charred meat, for
That's
instance,
the issue, though, isn't it?
Yeah.
Isn't it burnt?
Yeah. I mean, it's carcinogens. I mean, you're making all kinds of. It's a witch's brew of nastiness that tastes good. But, the reason why it tastes good is because the humans who survived learned to use fire to kill off the bacteria in rotten meat. And so the flavor of that probably was engineered into our evolution. But again, it's a cost benefit.
But didn't the cooking of it also allow us to absorb more protein?
I'm not sure about that.
I believe so.
Okay, that could be.
I believe that's the case, that cooking meat actually allows it to be more easily absorbed by the body.
It could be broken down more readily.
Yeah.
But certainly it kills bacteria. So, day-old or 3-day-old deer.
Right.
That you
We're
just
not
killed.
a bear.
Or not, yeah. Yeah. So, I mean, we're not vultures that seem to have digestive systems that can handle all of that.
So you should eat less meat. What else? Do you avoid sugar, which seems to be a real problem with cancer?
Yeah, I avoid too much sugar. Yeah, thanks for this, by the way.
Is that sugar-free?
No, but it's
that
okay.
one's not?
No, it's okay.
Oh, we have sugar-free ones.
No, because the sugar-free ones have stuff in them that are just as bad as xylitol and all the others.
What about Zevia?
Yeah, that would be good.
Stevia bad for you?
I don't think so. I haven't seen anything on that. But, I mean, look, like I said, I'm 64. It's way too late. And every time that, let's say, scientists make some grand prediction of what's good or bad, 5 years later we find and update what it should have been. I mean, I often say this, and this is true. The goal of science or scientists is to be right today, even wrong today, but righter tomorrow. Because we're always back-checking what the results are and what they mean in the context of a bigger picture.
I like how you say good science, because that's part of the problem, is that ego gets attached to ideas that have already been discussed and published.
Right.
And then people are very reluctant to accept new evidence that's contrary to that.
Yeah, I mean, as always, as I often say, in the context of something I know we'll get to later, it's the data off the curve, which is more important than what we already predict. Predictions are great, but when there's a data point off the curve, at least in my lab, that's where we spend the most time at our lab meetings, is trying to figure out why that data point's off the curve. Is it because the machine was wrong? It was a glitch? Or does it mean something that we need to make sense of? And that's, of course, where all advances come from in the sciences, is by the fact that the data off the curve, somebody was curious enough about what it meant to go after it and then say, okay, now that I've stepped back and see the bigger picture, now I can create a model that incorporates that data point off the curve and why it happened.
One of the reasons why I was really excited to have this conversation with you about the research that you do is that I think it's really important to illuminate to the general public the sheer scope of the task of trying to figure out what is going on in all these different things that can go wrong and right in the human body.
Yeah.
And that it requires this fucking insane amount of work by many, 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 many people.
And, and then the amount of data that had to be collected now. And so here's the difference, is that, there's data, there's evidence, there's conclusions and proof, and that's an uphill climb. But proof, the next one up is meaning. My lab has been largely responsible, at least partly responsible, for the data deluge that's out there in the world, both in how to do tissue biopsy analysis, how to do single-cell analysis, et cetera. And, data felt good for a while. It was like this, this feedback loop of, oh, wow, I can get all this data. And then suddenly you look at it and you go, well, what the fuck does it mean? And so humanity has this habit of backing itself into a corner and then suddenly finding this eureka moment that gets it out. And so our eureka moment about 2 years ago was artificial intelligence, where suddenly I had the ability. So normally I would collect all this data and go, okay, well, it seems myeloid suppressor cells are important here and T regulatory cells are important here. Okay, I get on the phone or send an email to whoever the local expert is, either on Stanford campus or around the world, and try to get some information from them. But then now you're dealing with hundreds of cell types, each individually of which have thousands of variations themselves. And each subtle variation means something. And there's no expert for any of that. But AI can be, at least in part, that expert. So suddenly I have 22 million papers published, in all the fields of science, several tens of millions just in, or several millions just in immunology alone. And AI can be the sleuth for me, can be both the angel and the devil on my shoulder that can make sense of things in ways that I never would have been able to before, especially with agentic AI. So we, for instance, in my lab have developed an agentic AI that is basically an immunologist scientist in a box. We can give it the raw data and we can pose a question in natural language. And then we say, hey, make sense of this and turn it into a network. Normally, that would have taken a graduate student along with a couple of postdocs months and months and months to put it all together. Now, in 3 hours, we can get pictures and hypotheses of how all that data fits together in ways that I never could have done before. At the beginning, it did a lot of hallucinations, which you probably heard about in AI. But my answer to my colleagues is some of my best students hallucinate. Right?
Right.
And so, but, the human's still in the loop. And so with all of this together, now we can make meaning out of the data. And we can skip a lot of the intermediary steps and speed it up. And it's just getting better. I mean, we, for instance, have put in a couple of papers now where, so for instance, where one of my recent specialties is what's called the tumor-immune interface. So you have the tumor, you have the immune system, which is coalescing on, near, and then in some cases the tumor creates a boundary, a barrier between itself and the immune system, where there might be certain kinds of cells that the immune system, the tumor has told the immune system, ignore us, we're not here. But what we now can do is on the other side of when you look at, let's say, complex patient populations, you find these things called tertiary lymphoid structures. So your body has 220 or so lymph nodes, okay? And the lymph nodes are where the immune system makes decisions, let's say. It turns out that in the middle of tumors, the body has evolved a mechanism to create what essentially looks like a lymphoid structure in the middle of the tumor. It's sort of a forward camp of immune cells that the more of those you see in a tumor, the better will be your outcome as a patient. And so we used a cohort of colorectal cell, basically colon cancer patients, where we looked at hundreds of biopsies. And we did that pseudotime analysis where we looked for mature tertiary lymphoid structures. And then we looked for immature, slightly less mature, even more less mature, et cetera. And we were able to backtrack to the cell types which need to come together that would then form the more mature. What use is that? It's a nice paper, but it also now tells us what we might do to create more of these in a tumor. Because the more, we already know from multiple kinds of tumor types now, that the more of these tertiary lymphoid structures you have, the better off will be your outcome with chemotherapy. So it might be, for instance, that once we know that you have a disease like this, we could give you some kind of therapy, a virus or what have you, that goes and homes to the tumor, seeds the beginnings of these initiators with, there's these cytokines that are produced that are necessary for initiating the formation of these objects. And so there's a huge benefit to that, but we never would have found those, in my lab at least, without the AI, because
Wow.
it basically did the work for us.
That's fascinating.
Yeah.
Now, are you using like a standard large language model, or do you have like a specific structure that's built that interfaces with large language?
Correct. So we use, we can use pretty much any of the LLMs, but right now we find that OpenAI is the best, for us at least. And then we create an agentic overlay. Basically what's called, you probably know, chain of thought, which is a series of questions. So how we taught it was we basically came up, here's 100 kinds of questions a scientist would ask about the immune system. And then we tell ChatGPT, now create 1,000 questions like this. So, it's artificial data or artificial questions. We curate those to make sure that they're good. Then we do 100 hypotheses, and we create thousands of types of hypotheses, et cetera, and the same for tests that you might run. So now, from A to Z, we have an agentic AI that you give it raw data, it knows what to do with the data, it then generates hypotheses for you, and then it literally tells you the kinds of experiments you should do next to prove or disprove the hypothesis